Okay, so you can do subnetting, but can you do it backwards? It sounds like one of those dumb things you would say when you're a kid. Yeah, you can ride that bike with no hands, but can you put your leg over the handlebars when you're going? And by the way, I did that and lived to tell the tale. This is not trivial, though. This is actually, believe it or not, the most common form of subnetting that you're going to get. That is, most of the time, you're not going to be rolling out new networks, architecting a new subnetting solution. You're going to be in the field. You're going to be staring at a computer like, why is this not working? You've got an IP address, you've got a subnet mask, and you're like, is that right? That's where reverse engineering a subnet problem comes in. So by the time we're done here, we will explore the process of reverse engineering that subnet problem. And I want to make sure you know that this is not for mere mortals. I'm assuming that you've already got a basic understanding of IP addresses. You know the classes of addresses like class A, B, C. You can convert decimal to binary. And you know what I would call forward subnetting, or subnetting based on network and host requirements. That is, you take a block of addresses and chop it up based on various requirements. So all that needs to be in place. And the reason I say that is because I'm going right back to the 3 steps. Believe it or not, this is the most common form of subnetting that's out there, but it's also the easiest. You're going to like it the most because you can do it really quick. So in this video, I'm going to walk you through one example, and then we'll expand that to other examples in the upcoming videos. So here's the situation. We've got our Petropolis headquarters, inspired, of course, by Sonic the Hedgehog. You are troubleshooting an issue in store 7314, that guy right there. You notice a laptop has the IP address 192.168.5.68/28. Now, I know we don't usually see it that way when we're troubleshooting a Windows device. We would see something like 255.255.255.240, right? So you see that IP address, you see the subnet mask, and this can come at you a whole variety of ways. You can see right here, I'm asking, what is the network range of this IP address? But know that in the real world, it's going to be more twisty than that, right? It's just going to be not working. You're not going to be like, what's the network range, or what's the broadcast? What's the network? What's the, like all those things are more like, if I were taking an exam, I would ask a question like that. In the real world, I'm like, it's broken. What's the problem? The good news in all of this is we actually have the answer to the traditional subnetting issue right in front of us. Remember, when we were going through the 3-step subnetting process, when we were trying to figure it out based on the number of networks and hosts and all that kind of stuff, our whole goal was to figure out what the subnet mask is, right? We're like, okay, how, we've got this big subnet. We want to break it up into more subnets. So how do we figure out what that subnet mask is? Well, in this case, in this reverse engineering world, we know the subnet mask. They gave it to us. So essentially, they're giving you the answer that we would normally try and figure out. And it's like, okay, well, can we walk that backwards to figure out what those network ranges were? Or another way of saying it is you're kind of starting from right here. I mean, look at it. Hang on, let me flip back to a slide. You're in the store, right? You have a device. It's got this IP address and it's got this subnet mask. So you're already at step 2. You've already got 192.168.5.68. Hang on, let me just grab my pen. 192.168.5.68/28. So that would be the answer we're trying to figure out in step 2. So all we've got to do is walk that forward. So I'll do equals. So break that into all binary, right? So I'm just going to go ... because we know a class C subnet mask is a / what? 24, right? Right? So I'm just going to say, yeah, that represents 24 ones, because I don't care about all that. I care about the increment. I want to figure out where those networks came from. So I'm going to go 1, 2, 3, 4. I've got my 24, 4 more. Last bits look like this. This is the lowest network bit. Convert it back to a decimal. That'd be 128, 64, 32, 16, right? So this is our increment. So at some point, now this is just an IP address. It's assigned to a computer sitting in store 7314, whatever it is, right? It's a computer that's having problems, right? So at some point, when they were figuring out this subnet scheme, they would have started from 192.168.5.0, right? So if the network architect that's out there is like, okay, let's design this network. We've got Petropolis, all these stores. Let's start from zero and let's increment our way down. Well, so that's already been done, right? We've got an IP address that's sitting there not working, 192.168.5.68. We're like, okay, well, let's see what network range it comes from. 32, 48, 48 plus 16 is 64, right? 80. Hold the phone. Right there, 192.168.5.64 through 79, right? So right there, the answer to the question is this IP address came from this network range. That's the network ID, that's the broadcast, and on an initial glance, it looks good to me. I'm like, okay, it's 68. So that gives us one puzzle piece when we're troubleshooting this issue. And in this nugget, this video, that's where I'm going to leave it, because that's where the troubleshooting begins. I mean, maybe that's not the right network range for that store. Maybe the gateway is on the wrong, maybe the default gateway was misconfigured. Maybe it's the wrong subnet, maybe a whole bunch of things. My whole point in here is not to do the troubleshooting. That's going to be the next video where I give you, I'm going to do my thought about this right now is that, you remember, maybe you don't. I remember when you would go to the dentist or doctor's office when you were kids, they would always have magazines in the lobby. And they would always have highlights for kids. Does anyone remember that? Or am I the only one? Okay, highlights for kids. What was your favorite page in that entire magazine? Come on. I know somebody's like, I'm too young for highlight. So it was always what's wrong with this picture. Like you would flip to it and you're like, oh, the monkey's holding a toothbrush. Like monkeys don't hold. Oh, and you'd feel so good as a kid, but all the other kids would probably have circled it before you. So you always get the used up page. Anyway, what am I talking about? That's going to be the next video. I'm going to kind of throw a network situation up there, and you're going to use this reverse engineering skill. We're going to use it together to do kind of like a what's wrong with this picture situation and see how many errors we can find in a network environment. For now, that's the process of reverse engineering a subnet problem. Please, please, please take the time. Move on to the next navigate because that'll really solidify this skill. For now, I hope this has been informative for you, and I'd like to thank you for viewing.